how do they like to take volumes and make it different is what if the shape that we're rotating around is no longer a disc or no longer a cylinder or no longer a washer or whatever you want to think about. What if they change it to another shape? The idea is the same. You just have to pay attention to what shape they say. Oh, look at me, like just typing this all out here. Normally, when we do the cylinder, we take the area of the base, which is the pi r squared. Pi we pull out front. The r squared is our function, and then the height becomes our dx or our dy, because the closer those rectangles get going towards an integral, they go to 0 or the dx there. So basically, to find the volume using any shape, all you have to do is take the area of the base, and if it's a cylinder or a disc or a washer, then we just do pi r squared like we've been doing. But they like to change it to other things, and mostly what you use is squares, like that's the example that they give you, but every now and again they go crazy and give you some other shape. But you just have to read the problem and see what shape they say, and so let's look at one of these. Well, usually they use squares. Can you tell I had this planned for when I was having a baby? Like I typed everything out here. So if they use a square, think about that you could just do the integral of the area of a square instead of the area of a cylinder. And what is the area of a square? But in a square, what is the base and the height? The same, right? So if I called this x and I called this x, the reason they use a square so much is because just like pi r squared, you just need the radius. You just need one side of the square, which guess what? It's usually the function. So we could say that this would be the integral from a to b, maybe I should call this s, of side squared ds. I have to change that to.
Patrick is really good at making integral signs. And I couldn't stop noticing that he was left-handed.
He is left-handed.
I was watching it. It bothered me, but he has really good handwriting, especially for a guy and for being
I'm telling you, when you go to college, if you learn something and you have no clue what it's about and it's math related, look up Patrick JMT and whatever the topic is, and he probably has a video, and it's pretty smart. Like, he's a pretty smart guy.
He's really good at integral signs.
Okay, I get it, Katie. I get it. My integral signs suck. Oh, look at this lovely shape. This is from an AP test. Says, the base of a loudspeaker is determined by two curves, y equals x squared over 10 and y equals negative x squared over 10 for 1 to 4. And they've given you this lovely graph, and they even show you what it's like if you rotated it. You don't even have to visualize it. As shown in the figure above. For this loudspeaker, the cross sections perpendicular to the x-axis are squares. That's the key idea when you do these problems on the AP test. You have to read the problem, because if you don't see that it's squares, you're going to set it up like we've been doing it. You're going to put pi in it, and I guarantee one of those answers has doing it with pi in it. And then you're going to get the wrong answer. What is the volume of the loudspeaker in cubic units? If we're rotating this around the x-axis, what are my bounds going to be? What's wrong with you?
I just realized I know how you asked my siblings if they could do a Katie voice. Was Mr. Stewart in here with you? No. Because I just thought of that, and I'm like...
No, he wasn't in here. He wasn't in here, was he? No, he was not in here. And I didn't even realize your siblings were in here. I was just talking to Caitlin. It was supposed to just be me and Caitlin, but then Caitlin asked your siblings. It wasn't me. It was Caitlin.
I'm just saying, but if he was in here, then I don't know if I would forgive you.
You'd forget. Because we're talking about squares, we need the area of a square, which is just the side squared. What do you think the side of the square is going to be of this? Instead of drawing disc or like rectangles, could I pretend I'm drawing a square?
How do you know where the square is even supposed to go?
How do you know where the rectangle is supposed to go? You don't know. You just draw a rectangle, right? Over like perpendicular to the axis. You just draw a square. Here's the whole idea that I'm trying to get across to you. It's the same thing we've been doing, except for we're talking about the area of a square instead of the area of a cylinder. Which means the top of that square going to be in this problem? This top function, and what's the bottom of that square going to be? Let's pretend we do it like we did before. If I drew this in as a rectangle instead of a square, do you see how it's this function minus this function? There's no hole going on there, just top minus bottom. But what's different? Instead of being a rectangle, instead of being a cylinder where we do pi r squared, we're just going to do the side squared, which just means we're just going to take top minus bottom, or we're just going to take x squared over 10 minus negative x squared over 10 squared. And I don't need pi, right? Because pi is not part of a square. And guess what? These are all decimals, which means these are from the calculator part of the test, which means what could you do now? Integrate with your calculator. It's all about getting the setup right. So someone type that in there. Calculadora there.
What do people call it?
That's the Danish word for calculator.
I thought people saying that it sounded stupid.
Computadora. That's computer. Biblioteca. That's what I'm doing. That's what I heard.
Okay, so
Pregunta. That's a question. My Spanish teacher was always like, pregunta? Vaya baño, por favor. May I use that, please?
I've never had
It's the most important thing to know in English.
Our teacher wouldn't let us go to the bathroom in Spanish class unless you asked Spanish.
relevant. Or she won't translate anything to you. She says, I'm not translating.
Yeah.
Victoria's mom teaches
What'd you get? Did you get one of these? I got D.
school, and like they just
Multiply that answer by pi. Not because it's the answer, but just because I want to show you that I'm pretty sure that's E. You take that times pi. So you got to remember to pay attention. Almost always are squares because they throw something else in there. Yes, you start reviewing for the AP test. We'll look at maybe some other ones, but I just want to show you this. Is this the only example I have on here? And I just have a little advice for you, right?
Yeah.
Just read the problem is my big advice, because if you just read the problem and you think about the area of whatever shape they're talking about, and don't put pi there if it's not a dishwasher, but don't forget pi if it is a dishwasher. On that. What else do I have for you? I actually have two things for you, maybe. So exciting. We actually have some time left. How about this for throwing us off here? Because of ISTEP, tomorrow's pride time is going to be in the afternoon, and Thursday pride time is going to be in the morning. Which means, yes.
I just don't have time.
Well, we weren't going to, but then they changed it. So my morning message said that this morning. Ridiculous. So that means Thursday is when we're having our test. I cannot stress enough how much you should be here early on Thursday to start that test early.
We're not having it on Friday? We have to have breakfast, so we'll be
We're
here.
not gonna be here Friday.
I thought we were gonna do it Friday.
Well, I think we can just get it in on. So today's our last step, which means tomorrow we can do a worksheet review, and then Wednesday you can do a book review, and then Thursday we have a test. We can have a little study session in the breakfast, Friday morning, Thursday morning. Wait, what are they doing?
We're feeding them.
It's just pancakes.
Why are people saying we're feeding them? Is that
Normally, the seniors are down there with Mr. Bain and Mr. Huckett and Mr. Griswold, usually, but maybe not Mr. Smith, and help with cook. One
I
year,
thought
the
that-
seniors made me pancakes and potato pie. Just saying.
maybe it was one.
Well, I don't really care enough about school anymore.
I thought that Patrick I listened to on the video sounded like a teacher.
You like the humming noise of the video?
No, that's all right.
All right, this is your homework worksheet, but before you start on the homework, I have a free response question I want to look at. Just so you know, on all of these problems, there's one back. The one on the back just says write but not evaluate, so that's okay. But the two on the front, set it up, and then you can use your calculator to integrate it. I just want to see the setup. Now let's look at this one. This is a free response question that I think we can actually do all 4 marks now. What do you think about that?
So we're gonna do it right now.
You're going to start it right now, yes.
Start it as in we're not gonna have time or like.
As in, I want to see what you can do by yourself before I just do it all for you, right? But look at part A. It says, use step one, you might want to kind of sort of graph this. I just wanted to show you this because I just wanted to see how it puts everything together that we've been doing. Plus, what makes free response more difficult is part C and D. Like, they take things that we know how to do part A and B, and then they're like, ooh, let's go in something extra difficult. And again, this is without a calculator at all, which means that, you should be able to get a decent little graph here. Just going from 1 through 4. Pay attention that it says the first quadrant, so that's how you know that the x and y axis are also bounds, which means we get that little sort of triangle-ish shape, maybe more like a ramp shape because it's slanted. Left ring on sums, you remember how to do that? Remember on free response, you want to show the setup. Don't just show an answer, but I would think without a calculator, you would need a setup. You want to use 4 subdivisions, which works out really nice that you're going 0 to 4. And remember that you take the length times the height of those rectangles. So if you wanted to, you could even draw in left ring on sums means you would be using these heights, right? Like that. And the width of those are all the same, but if you want to just make the width of each one 1, and the height is going to be what? Yeah, plugging in the left endpoint of each one. And remember, without a calculator, if you just plug that in, you don't even have to work it out, which I find super awesome. Makes me feel like I'm not completing my math problem. Right, you don't actually have to work it out. Right, like I think this is what I'd be doing. Like I would plug in 0, 1, 2, and 3, not plugging in the right endpoint because I don't actually get there. If you left your answer like that, like you would get credit for it. That would be what, 1 over 1/2 plus 1/3 plus 1/4. If I didn't, if I was doing this, I would leave my answer like that because I wouldn't want to, 1, waste the time getting a common denominator, and 2, you don't want to risk missing the problem when you might add it wrong. But just in case you want to know, I think it's 25 over 12. You with me on that, part A? What about part B? Part B says find the area of R. And if you read back up, R is the region, this region right here. So part B, area of R. This is what we did in step 2. Seems like a long time ago, but it really wasn't. When we just found area, how do you just find the area under a curve? Integral from 0 to 4. It's just one function, right? So it's just 1 over x plus 1. I don't know why I put that in parentheses, but Remember, we're not squaring it. We're not putting pi in front of it, right? That's what we do when we find the volume. And so remember that area is just the area under the curve. This is without a calculator, which means you know how to integrate that? What? Yeah, you could do u substitution and get 1 over u, but it's just going to be ln, right? Either way that you see that. Again, remember, without a calculator, you don't have to simplify all the way, but you do need to at least plug your numbers in. And so, like, this would be ln of absolute value of x plus 1. I don't think that really plays a part here, but if it was negative, remember you do. From 0 to 4. So we could say that's ln of 4 plus 1, which is 5, minus ln of 0 plus 1, which is 1. And again, you can leave it like that, but what is ln of 1? 0. So I'm going to go ahead and say that the answer to that is ln of 5. Now what about part C? If you haven't already read that one, read it, and let's think about it for a minute and see if maybe we can think about a setup here. It says let x equal k be a vertical line dividing R into two regions of equal area. Find the value of k. And again, I remember in years past, I have the way that I do it, and then there's always been one or two people that come up with another way to do it that works out to be the same answer. I find there is about less difference. Say that again. Well, we found the total area already, right? What do we find the area to be in part B? ln of 5. So Sean says if we know the total area, set the equation equal to that to find the x value, which I think might work, except, and my only concern is, do you know how to do the algebra to get that to work out? And maybe you do. I don't know. Write it out and see. Here's what I did, and you tell me if this makes any sense. If this, I just drew in some k value. I know that's not necessarily where k is. But I said, if these are equal, does that mean the integral from 0 to k of my function has to equal the integral of k to 4 of that same function? And I wrote in the actual, what is it? 1 over x plus 1 dx. 1 over x plus 1 dx. And there's a lot of algebra in this too, which is why, Sean, I'm not sure. I feel like there's been some other way, which means that probably would work. If you said ln of 5 equals that, what would you do? E both sides, but then you need to solve that for x, which is the ln of 5 divided by 2, is that what you said? I don't know. Work it out. See if you get an answer. Why I do this, because this is a lot of work also. Definitely there's points on this for just the setup of this. Like if you got this part, like you would get points of this. And then you got to integrate this. And now k is going to be in our problem that we have to solve for, right? So this would still be ln of x plus 1 from 0 to k. Set it equal to ln of x plus 1 from k to 4. So this would be ln of k plus 1 minus ln of 0 plus 1, which is 1, equals ln of 5 minus ln of k plus 1. Trying to solve for k here. Again, ln of 1 is 0. Very nice to know that. Can I move this ln of k plus 1 over to the side? If I add that over, and I'm just through the like term, so I'm just going to say that's 2 ln of k plus 1 equals ln of 5. And you can see this is kind of a stretch here. It's kind of a crazy problem, but if you can have an ln equal to an ln, then the stuff in between like has to be the same. Is there a way I can put this 2 in here? That's the same as saying ln of k plus 1 squared equals ln of 5. Which means I can say that k plus 1 squared equals 5. Notice I dropped the absolute values because if I square k plus 1, it can't be negative anymore. Now I can take the square root. And I would get that k equals plus or minus the square root of 5 minus 1, right? Think about the area up here. I'll shut down. Could k be a negative number in my region? Which means you would throw out the negative answer. Like you would say the answer is just the square root of 5 minus 1. Because you can have negative up there. That's a bit crazy. Right? This is actually from a practice book. This is not a real AP test question. I like to think that this is harder than a real AP test question. But look at part D. I really want to give you this one just to look at part D because I said almost always they're squares. And again, this is a practice AP test, not a real AP test. But look at that part D. It says, let the base of a solid be the region R. If all cross sections perpendicular to the x-axis are equilateral triangles, set up but do not integrate an integral expression to find the volume of that solid. I find this to be ridiculous because you know how to find the area of an equilateral triangle? In terms of, like, instead of doing 1/2 base times height, they're wanting you to know the formula that you learned, like, in geometry. It's like the square root of 3 times the size squared or something. It's super ridiculous. Isn't that stupid? I agree. Well, you could do 1/2 base times height, but the problem is, what would the base and the height of that be? You see what I'm saying? Like, you can always use 1/2 base times height. Look at me pretending I'm still going to write with this. We could derive the formula. If this is an equilateral triangle, right? You could do 1/2 base times height, but the thing with these problems, if you're rotating it, you really can't use two different things. Like, you usually just need the function. If you drew this height in here, do you agree that this would now be 1/2 s this side here? And we could do Pythagorean theorem to figure out what this is. Yes? This is now, I think, going to be a 30, 60, 90 triangle. Is that true? Which means that, do you remember the ratio for a 30, 60, 90 triangle? 1, 2, square root of 3.
Okay, why isn't it 30?
Because it's equilateral. So that means this is 60, this is 30. So we could do Pythagorean theorem, or I would just use my ratios and say that this has to be the square root of 3s. Which means if you were going to find the area of this, oh my gosh, this is terrible. 1/2 base times height, the base is s, and the height is the square root of 3s, which means it's square root of 3 over 2s squared. Square over 2. That's ridiculous, and I don't think there would ever show you that every time you do this, it has to be something square shape that they give you, because I don't know how else that we would set that up. But two different shapes. That's exciting, right? Compared to this that we just did, this worksheet is not bad at all. Every single one, they're talking about squares. You can use your calculator, just set it up, get an answer. There's only 3 of them. Tomorrow we're gonna have a worksheet. I had a 7-1, 7-2 worksheet, and I have a 7-3 worksheet, which means I'm probably gonna put that somewhat together, not the whole worksheet on each one, but I want to go back and give you some 7-1 and 7-2 review also. I'll try to get that done by 4th hour. So if you want to pick it up, especially those of you that have study hall later, I know we think you're out of here, but I might be able to get you one and just cross out the ones you don't have to do. If you want to come back and see me after 2nd hour. If you want to, because today's homework's not going to take very long to do. If you're caught up on your homework and you want to go ahead and get the worksheet to start on, because it will be a longer worksheet than normal, I'm okay with that. If you're not caught up on your homework, you might want to get caught up on your homework, because I don't think we've had homework for this chapter. Just saying. I'm not going to be here Wednesday because I'm going to the Children's Museum with Parker. So we'll have the worksheet tomorrow. I'm going to leave a book review for you on Wednesday, and we're having a test on Thursday, and that's plans. I'm also going to give you a practice AP test sometime. Maybe we'll do that tomorrow too, since I won't be here on Wednesday. Maybe I'll just give that to you at breakfast on Friday. I don't know. There's no time. The senior breakfast on Thursday. Thursday. Whatever. Go. Well, we have this test, which will be on this 9 weeks. But we will have practice AP tests that I grade. I'm not going to grade them like a normal test. Like like the first one I give you, I'm going to give you one for over spring break. That's going to count as a grade, and we're going to talk about that. That's why I want to give it to you. We got this whole letter that I give to you about how I grade it. But we'll do that. We'll do free response quizzes, so that's kind of how you get your quiz grades. And then we will do some, as we do the review, that'll be homework grades. And so each AP test, I obviously curve. The more AP tests we do, the less I curve it, if that makes any sense, because I expect that you do better each time. But that's where your grades come from. So the test grades come from AP tests. We'll do at least one AP test during class, so that we can kind of get the feel for it. We'll do free response quizzes. That's where quizzes will come from, and we'll actually do review for homework. But you will have this chapter 7. Chapter 7 homework, chapter 7 tests will also count for this. Okay, but a lot of people end up with decent grades for the second 9 weeks because I do curve it, not necessarily based off a high score. Some people might get, like you might get above the high score, and so like you can get extra credit on your test a lot more on this stuff. And you can get extra credit on the free response quizzes because I take them out of the average. So if the average score on free response I give you is 4 out of 9, and you get 7 out of 9, then you get 7 out of 4 grade book. So definitely some chances to get extra credit. Okay. I don't. I took home all the subject grade, and I took home the key for the retest.